Hello students, welcome to today's lesson. I'm teacher Alice. We are still looking at chapter 3 of Form 3 Chemistry, and that is Organic Chemistry 1. And today we are going to start looking at what we call alkenes. So this is another category of hydrocarbons. We have been looking at the alkanes. So today we look at the second part, which is the alkenes. So this is part 5 of this chapter, and we start by looking what we call nomenclature, or the naming system of alkenes. So we say that alkenes, these are hydrocarbons. These are compounds containing carbon and hydrogen as the only atoms. So we have alkenes as hydrocarbons. They have a general formula CN, H2N, N and 2N are subscripts, and they also have a carbon-carbon double bond. Remember, like for the alkenes, we had a single bond between a carbon and a carbon, but for alkenes, we have a double bond between two carbon atoms. So N in this formula represent the number of carbon atoms. So if we have, for example, CN, N be it 2, this one will be an ethene, meaning hydrocarbon with 2 carbon atoms and 4 hydrogen atoms. Then these carbon atoms, we have said they are linked with a double bond and a single bond to hydrogen atom. So we have, if it is for ethene, the carbon will be a double bond, but for the carbon hydrogen, those will be single bonds. All right. So these alkenes, we can look at the first 10 members of the alkenes. So these are the first members. We start with ethene. So there's no alkene with 1 carbon atom. So alkenes starts from ethene, 2 carbon atoms, and then 4 hydrogen atoms. So that is an ethene. Its molecular formula is C2H4. That is the molecular formula, or what we call the general formula. Then this is the open structure. You can see that the carbon hydrogen is a single bond. Then a carbon and a carbon is connected by a double bond. Then this is also the structural formula. From there we go to the alkene number 2 is the propene. Propene has 3 carbon atoms and 6 hydrogen atoms. This is its open structural formula, and this is its closed structural formula. So you can be asked to give the molecular formula or the general formula, or you can also be asked to give the structural formula. So if it is not specified whether you can, if you are just told give the structural formula of propene, you can choose to give the open structural formula or the closed structural formula. Then the next member of alkene, we have the butene with 4 carbon atoms and 8 hydrogen atoms. Next we have pentene with 5 carbon atoms, 10 hydrogen atoms. Then we have hexene from hex meaning 6. So 6 carbon atoms and 12 hydrogen atoms. Then we have heptene, 7 carbon atoms and 14 hydrogen atoms. Next we have octene, nonene, decene, and so on and so forth. So these are the first 7 members of the alkenes. We have their molecular and structural formulas. So since carbon is tetravalent, it must be bonded by what? By four covalent bonds. So for an alkene, where we have single bonds, then the carbon atoms must be connected with other two bonds, whether to hydrogen or maybe to another substituent like a halogen. So we must have 4 covalent bonds for carbon. Then for hydrogen, hydrogen is a monovalent, so it must be bonded by what? 1 covalent bond. So the bond joining carbon and hydrogen must be a single bond. Then just for the alkenes, even alkenes differ with a CH2 group. So from ethene, if we add a CH2 group, we get a propene. From a propene to go to butene, we have to add a CH2 group. So this is what we said forms a homologous series. Then we looked at the properties of a homologous series. So alkenes belongs to a homologous series just because they do what? They differ, the members differ by a group, a CH2 group from either the previous or to the next member. So these are the properties of the homologous group of alkenes. One, they differ by a CH2 group. Two, they have similar chemical formula represented by the general formula. We have said it is CnH2n. So they have that general formula. And the physical properties of alkenes shows steady gradual change. So there's a relationship between the what? The properties or the physical properties of the alkenes. Okay, then the carbon double bond in alkene is the functional group. What do we mean by the function being a functional group? This is the reacting site of a compound. So this is where most reaction take place, or where the reaction will start. All right. So between them, carbon and carbon with a double bond, this is where the reaction of that alkene start. So the reason behind the carbon-carbon double bond being the reacting site is because it can easily be broken to accommodate 2 more monovalent atoms, meaning one covalent bonds. So you can break it during a reaction. The double bond is broken, then we are left with 1 bond. So the carbon will be connected to how many bonds? To 3 covalent bonds. So meaning it can accommodate another 2. So we are left with 2 covalent bonds, meaning that we can accommodate 2 compounds that have a single covalent bond. So the carbon-carbon bond makes the alkenes to be unsaturated. So we have 2 hydrocarbons that are unsaturated. One, now we have seen it is the alkenes, and then what we are going to look later we call the alkynes. So the double bond in alkenes and the triple bond in alkynes makes these hydrocarbons unsaturated. Okay, so an unsaturated hydrocarbon, if you are asked what is an unsaturated hydrocarbon, you can say it is a hydrocarbon with a triple or double bond. Then for saturated hydrocarbons, we say these are hydrocarbons that are done what? That does not have double or triple bond. For example, the alkanes, we saw that they are saturated since they have what? A single bond. So during a reaction, it is very easy to break the double bond. So it is easy to saturate the alkenes. So when we break a bond, it becomes a saturated hydrocarbon, right? And we have said that most reactions will start or will take place between these two carbon atoms with double bonds. Okay, then we can look at the naming system now. So naming system or the nomenclature is always guided by certain rules or certain principles, not very different from those of alkanes. If you still recall how we give names to the alkanes, this is the same way we name the alkenes. So the first step in naming alkenes, one is to identify the longest continuous or what we call straight carbon chain, which contains a carbon-carbon double bond. So the longest carbon chain must include the carbon-carbon double bond. So even if you find the longest chain and you find that your double bond is in the branch, so that is not the what? The longest carbon chain. So the longest carbon chain must contain the carbon-carbon double bond. So why do we identify the longest carbon chain? It is to determine the parent name of the alkene. So after you identify the longest straight carbon chain, it will give you the parent alkene. Then after you identify, step number 2 is to number the longest carbon chain. Then you have to start from the side we have the carbon double bond. So from where there's the double bond, that side where it is near the double bond is where you start naming. That will make the double bond have the lowest number possible. So if you start from, let's say, the left side and the carbon-carbon double bond, you find it at carbon number 4. Then you start at the right side and you find that the carbon double bond is at carbon number 2. Then you choose the side that is from the right. Right? So the carbon-carbon double bond must have the lowest number possible. That is step number 2. Step number 3 is to indicate the position of the carbon-carbon double bond. So you have to, while giving the name, you must show or you must give the position of the double bond. All right? So for example, if the carbon double bond is at carbon number 2 and this is a butene, then you have to show that it is at carbon number 2. So the name will stop being butene, but it will be but2-ene. All right. So if it is for pentene, if it is at carbon number 1, that is pent1-ene. So that one we can just call it pentene. But if the double bond is at carbon number 3, that one becomes a pent3-ene. Then if there are two, so it is not necessarily double bond to be 1, we can have 2 or more double bonds in an alkene. So if we have, for example, a pentene with 2 carbon double bonds, one at carbon number 1 and the other one between carbon number 3 and 4, that one will be a pent 1,3 diene. Remember, di is because they are 2. To show that there are 2 double bonds, one at position between carbon 1 and 2, the other one to show it is at between carbon number 3 and 4. So that becomes pent 1,3 diene. So that means we have to show the position. That is, if it is not at carbon number 1. All right. Then step number 4, the positions indicated must be for the carbon atom at the lower position. So if it is between carbon number 3 and 4, you will give the bond to be at carbon 3. So it will be pent 3 in. If it is between 3 and 4. If it is between 1 and 2, that one will be pent 1 in. So the double bond must be at the lower position of the carbon-carbon double bond. That is rule number 4, or the principle number 4. The rule number 5 is to determine the position, the number, and the type of the branch. Just like what we said in alkenes, you have to check for the substituent groups, or what we call the branches. We can have either the halogens or the what? The alkyl groups. Just as we give these names in alkenes, the same way we give to alkenes. So for the alkyl groups, we have methyl, ethyl, propyl, butyl, and so on. For the halogens, we have the fluoro from fluorine. If it is a bromine substituent, we call it bromo, iodo for iodine, and so on. Then, for these branches, you must show the position or the carbon atom that these groups or these branches are what? Are attached. So you must give the position. Guideline or rule number 6 is that you have to use the prefixes. The prefix, if it is for 2, you can use the di. 4, you can use the tetra. 5, you can use penta, and so on. So if the double bonds are more than one, you use the prefix. Also, if the branches are more than 1, we still use the what? The prefix di, tri, tetra, and so on. So that is the 6th rule. Then alkenes also form isomers. They form 2 types of isomers, what we call positional isomers and chain isomers. So position isomers are formed when you shift the double bond. If you can move the double bond from carbon, let's say it was but2-ene, then you move the double bond to carbon between 3 and 4. That one will be but3-ene. So but2-ene and but3-ene, these are positional isomers. So we can define position isomers as those compounds having the same general formula but different position of the functional group. So as long as the carbon double bond is shifting or is moving, that one is what we call the position isomers. So we can, for butene, for example, it has 2 position isomers. We have but1-ene, that is when the position of the double bond is between carbon 1 and 2, and also we have but2 in when we have the double bond between carbon 2 and 3, right? So like also for the alkenes, an alkyl group can be attached to the alkenes. So when we attach an alkyl group, that is a methyl and a propyl, an ethyl, so these are the alkyl groups. When they are attached to an alkene, they form what we call a chain or branch isomers. So we can also define chain or branch isomers as those compounds having the same general formula but different structural formula. For example, we have an example of a butene and a 2-methyl propene. All right, so these two have the same general formula. If you write the formula of the butene and that of 2-methyl propene, it will be the same, but they will have different structural formula. So that is what we call branch or chain alkenes. So we have seen that we have two types of isomers, the position and the branch, or what we are calling the chain isomers. So for alkenes, we have position or branch isomers. So we are going to go up to that point. In the next lesson, we are going to look at the preparation of alkenes, the laboratory preparation of alkenes, the physical properties, and maybe the chemical properties of what? Of alkenes. All right. So till then, if you got a question, you can, or a comment, you can leave it at the comment section. See you in the next lesson.